Uh, Hello, I just did a screencast or a tutorial of how to do Lewis structures, the way the book shows you how to do, but I'm going to do them. I like to do them just a little bit different with this. So I'm going to show you the way that I do them. You can do them either way; it doesn't matter. I like to do Lewis structures with molecules. So this is going to be talking about molecules. I like to do them to look how many electrons an atom has and how many it needs, and then look from there. So I'm going to do just a few Lewis structures to show you how to do them. So let's start out with the simple one, methane CH4. So I'm going to look at carbon. I'm going to say, okay, carbon, how many electrons? So how many electrons carbon has and how many electrons carbon needs to have a full octet. So carbon has 4 and it needs 4. Then I'm going to look at hydrogen. Now, if you remember, hydrogen is one of the exceptions that can be happy with 2 electrons in its valence. So it has 1 and it needs 1. So I'm going to start with the one that needs the most. So carbon needs the most electrons. So when drawing it, I'm going to start with carbon as the central atom. And then I'm going to put the hydrogens around it. Okay, so I'm going to have each hydrogen needs 1. So it's going to share 1 with carbon. That hydrogen is going to share 1. That hydrogen is going to share 1. And that hydrogen is going to share 1. Now, if I look at carbon, each one of these lines right here represents a pair of shared electrons. So carbon has 1 electron from itself. So if we look at this, carbon is sharing 1 there and hydrogen is sharing 1. So that's a total of 2 electrons. But instead of drawing those 2 dots, we just draw a line right there. So I'm going to go ahead and erase those off. So carbon has 2, 4, 6, 8. So it's happy. And hydrogen, remember, it only has to get 1 more to be happy. So it has 2 right there that it's sharing. So carbon's happy. All right, I'm just going to keep doing a few more of these. Here's one out of the book I did on the last tutorial. It was PCl3. So I'm going to say, I'm going to do carbon, how many it has, how many it needs, and then I'm going to do chlorine, chlorine, and chlorine. So phosphorus, it has a total of 5, so that means to get to 8, it needs 3. Carbon has 7, it needs 1. Or chlorine, sorry, chlorine is 7 and 1, and chlorine is also 7 and 1. So again, they all need to get to 8 except for hydrogen, which we talked about before. So the one that needs the most is phosphorus. So I'm going to come over here, I'm going to start with phosphorus, and I'm going to attach chlorine to each side right there. Chlorine, chlorine, chlorine. You know what, let me back up and explain something else to you. What I usually do to do this is start with phosphorus and draw its Lewis structure. So let's draw the Lewis structure for phosphorus. So phosphorus has 1, 2, 3, 4, and 5. So we look with phosphorus, I put all of its 5 electrons around it. Then I know where my chlorines need to go. So if you look, there's 3 spots right there that it needs chlorines on it. So I'm going to say, okay, I'm going to put a chlorine there. I'm going to put a chlorine there, and I'm going to put a chlorine right there. So if you look at that, phosphorus, I've used up 1, 2, 3, 4. I've used up all 5 of its electrons. Chlorine, I've used up 1 of its electrons, so I've used up 1 of its electrons. So I've used up 1 minus 1, so 6. I've still got 6 electrons left over I got to count for. So 1, 2, 3, 4, 5, 6. This one's the same way, minus 1 has 6 left. 1, 2, 3, 4, 5, 6. This one, minus 1, has 6 left. 1, 2, 3, 4, 5, and 6 of them right there. So I'm just going to keep doing a few more just to show you. Here is H2O. Okay, so we've got oxygen. It has 6. It needs 2. hydrogen has one and it needs one, and hydrogen, the other hydrogen has one and it needs one. So I'm going to start by doing the one that needs the most. So I've got oxygen. I'm going to draw its Lewis structure. 5, and so there's 2, 4, 5, 6. So and then the spots that it needs them right there, it needs one right there, so I'm going to put a hydrogen on. It needs one right there, I'm going to put a hydrogen on. So for oxygen, I have 1, 2, 3, 4, 5, 6, so -6. So I've used up all of its electrons. Hydrogen was sharing 1, so it's used up its 1. And that hydrogen sharing 1, so it's used up that 1 and it's happy. So let's do one that has a double bond like carbon dioxide. So carbon dioxide, we're going to do carbon has and needs. Carbon has 4, it needs 4. Oxygen has 6, it needs 2. Oxygen has 6 and it needs 2. So if you look at this one right here, each oxygen needs 2, so 2 and 2 is a total of 4. And if we go back up to the ones we've done up here previously, you notice the hydrogen, 1, 2, and it needs 2. Phosphorus, 3, 1, 2, and 3. So those should add up right there. So I'm going to start by drawing, I'm going to put carbon right here. Now for this one, I'm not going to draw its 4 valence electrons, because what carbon will do is, well, I'll just go ahead and draw it. So carbon's got 1, 2, 3, 4. It's not going to bond to an oxygen on each side. It's going to take these electrons. It's actually going to move these electrons down and move those electrons down. And it does what we call hybridizes its electrons. It moves them to a different level. So now carbon actually has, it has this. It's got electrons there and there. Okay, so it's hybridized or moved those electrons so it can bond with that oxygen. So I'm going to draw carbon. Oxygen needs 2, so I'm going to put the 2 from carbon that it needs, and oxygen over here has 2. It has a 2 from carbon right there. Okay, so now if we look at carbon, it's shared all 4 of its electrons, so those are gone. Oxygen, it's shared 1, 2, so that oxygen is -2. That means it's got 4 left over that it needs to have around the outside, so 1, 2, 3, 4. This one -2 because this oxygen shared 2, so 1, 2, 3, 4 left over. And that's what carbon dioxide looks like. Now, if you're wondering, why did I not draw it like this? Well, these are electrons right here, and they're negatively charged, and they want to get as far apart away from each other as possible, so it actually moves down there. It doesn't stay up there on the top, so they're getting as far apart away as possible as they can. So the next thing I'm going to do is come over here, and I'm going to draw one that has which is a polyatomic ion. The one in the book, let me go back and see which one they did in the book. And the one in the book is ClO2- right there. So for this one, we've got chlorine. Chlorine, we're going to do has and needs. So it has 7, needs 1. Oxygen and oxygen. It has 6 and 2 and 6 and 2, and then we've also got that 1 extra that's hanging out there. So we've got that 1 valence electron that's hanging out there too. All right. So if you look, this one's going to be just a little bit different, this polyatomic ion, because there's 2 oxygens and only 1 chlorine right there. So we're going to start with chlorine and put it in the middle, and we're just going to put 1 bond around. We're just going to bond our oxygens there together, and then we're just going to start adding up electrons to see what they do. All right, chlorine, it's going to have a total of 8. It needs a total of 8 valence electrons around it. So we're going to say, okay, this one has 1. It's got 2 4 around it, so it's going to need 4 more valence electrons around it. So if we look at total, that's got 2, 4, 6, 8 around it. Now for this one, we're going to add up the total right here. So, oh, sorry, I did that wrong. That one should be right over there. So if we add up the total, we've got 7 and 6 is 13, and 6 more is 19, plus 1 is going to be 20 total. So I'm going to take those 20 total electrons. I'm going to say this one has 2, 4, 6, 8. I'm going to subtract 8 from it. And so that gives me 12 electrons total. So with those 12 total electrons right there, that means I need to put these around the other ones. And if you look at oxygen, in order for oxygen to be happy, it's got 2 right there. It's got to have, that's going to be 4, 6, and 8. So now 2, 4, 6, 8, it's going to be happy. So what we're going to do is we're going to go minus 6 electrons from that one. That gives us 6 more electrons. So I'm going to put those 6 more electrons around that oxygen right there. So minus 6 electrons around that. That's going to be a total of 0 electrons. So I've counted for everything right there. So that's how you do ones with polyatomic ions. Let me do another one for you. Let me do NH4. It has a positive. That's an ammonium ion. So NH4. So we've got how many it has, how many it needs. So we've got nitrogen. Nitrogen has 5. So that means it's going to need 3 more. Hydrogen 1 and 1. Hydrogen 1 and 1. Hydrogen 1 and 1, and another hydrogen is 1 and 1. Now this plus sign means that it's missing 1 electron, so it's got to have a minus 1 electron. So we go 5, 6, 7, 8, 9, minus 1 is 8. So it's got 8 electrons right there that it can use. So we're going to start out drawing our nitrogen. So we've got nitrogen right there, and then I'm going to put the 4 hydrogens around it. 1, 2, 3, and 4 hydrogens around it. Now what we're going to do is we're going to add up all the electrons that we have, and then we're going to subtract that from 8. So I've got 2, 4, 6, 8, so minus 8 electrons. That one is accounted for. So when I do this, so it's got an overall positive charge, so I'm going to put it in brackets when I do Lewis structures for this, and it has a positive 1 charge. Now I forgot to do that on this one up here. So when I do this chlorine up here, this chlorate, I've got to do it like that and put a minus 1, and I forgot to do that on that one up there. Okay, so that's how you do Lewis structures